Hello friends, this is a problem on design of shaft. Let's start with the problem. A solid shaft is to transmit 1000 kilowatt at 120 rpm. Find the shaft diameter if the design shear stress is 80 newtons per millimeter square. If the shaft is made hollow with internal diameter is 0.6 times the outside diameter. Find the percentage of saving in material. So what the condition or definition is given is a solid shaft which carries 1000 kilowatt at 120 rpm and shear stress is 80 newtons per millimeter square. And in the place of solid shaft, if we replace a hollow shaft or if the material is removed from solid shaft and made it as a hollow shaft, then what is the amount of material saved, percentage amount of material saved, that we have to calculate. So the power P is given as 1000 kilowatt. Keep it as it is because in data handbook we will be substituting this one directly. So rpm, shear stress, so internal diameter is equal to 0.6 times the external diameter. So that means the 0.6 times the internal diameter will be less. So the term K is equal to the ratio of inside to outside diameter K. It is given 0.6 here. We'll substitute this one directly when it is necessary. Okay. So initially the torque transmitted by the shaft, that is solid shaft, T is equal to 9.55 into 10 to the power 6 P by N. So I'll be using design data handbook authors K. Mahadevan and Balveer Reddy, equation 3.3a, this one. So torque transmitted will be T is equal to 79583333.33 Newton millimeter. So keep torque transmitted in terms of newtons millimeter. It will be easy for your further calculation as well. So the diameter of the shaft, the equation is 3.1, that is solid shaft. Tau is equal to 16T by pi d cube. So we don't have diameter here, all other values we have. Substitute and we will be getting the value of diameter as 171.75 millimeter. So the standard diameter of the shaft is given in the data handbook. So the table number 3.5a, in that data handbook, see this one diameter, this is a calculated diameter. So you cannot consider diameter just as a full number or 172. You can consider, but when the data handbook is given and the standard diameter is provided in the data handbook, you have to consider that one. This is not wrong if you consider, but the answers are generated or answers are given in terms of standard diameter. So try to use this one. This is very mandatory. So the next step is diameter of hollow shaft. So same equation 3.1, tau is equal to 16T by pi do outside diameter. This is hollow shaft, that's why do cube minus 1 by into 1 by 1 minus k to the power 4. Okay, next, the torque transmitted irrespective of the solid or hollow shaft, the torque transmitted and the shear stress are same, they are kept equal, but just we are calculating only the percentage of saving of material. Okay, not any torque changes or stress changes we are not considering, we have kept it constant. So use the same value, you will get the diameter of the hollow shaft, outside diameter of the hollow shaft as 180 millimeter. So 180 is standard diameter because 179.88 data handbook same. So for 171.75 data handbook table 3.5a 180 mm. Similarly, this is 171, right? Here this 179. Same data handbook page number 3.5a. You'll get 180 as the standard diameter. Therefore, the inside diameter of the shaft, that is K equal to di by do. K is given, that is 0.6, and outside diameter we have the value of outside diameter, this is 180 mm. So di, we'll calculate di, that is 110 millimeter. So next, percentage saving of material. See, 108 what we will get is after calculation, but the standard is 110. Same table number 3.5a. okay, 3.5a you will get this value 110. Okay, next, the percentage saving of material, that is equal to solid shaft area minus hollow shaft area divided by solid shaft area into 100. So for solid shaft area, pi by 4 d square minus hollow shaft is pi by 4 into d outside diameter square minus inside diameter square divided by solid shaft area into 100. Substitute the values. Here we have solid shaft diameter, outside diameter of the hollow shaft, inside diameter of the hollow shaft. We have everything, so substitute the percentage saving of the material. If the solid shaft, the amount of material from the solid shaft, if we remove, the percentage saving of material will be 37.35% for this given problem.